Stop scrolling. If you want to see the one secret nobody is talking about, hit that subscribe button first. You won't believe the ending, but only if you stick around. New Orleans, 1941. The docks smelled of diesel, river mud, and war long before America officially entered it. Inside a noisy workshop along the waterfront, one man moved with a pace that made his workers snap to attention. Andrew Higgins was studying maps of island chains, beaches, and mud flats across two oceans. He saw the same problem everywhere. If the United States ever had to storm an enemy shore, conventional Navy boats would fail before the first shot was fired. They drew too much water. They broke on rocks. They died in shallow surf. And no one in Washington understood how catastrophic that limitation could become. Higgins understood it because his education came from the unforgiving waterways of the Gulf Coast, not from naval academies. He built boats for trappers, lumber crews, and the men who ran whiskey under moonlight. These boats were punished every day by sandbars, stumps, shifting tides, and narrow river turns. Higgins learned exactly how it flexed, how a hull behaved when pushed off balance, and how to keep a craft moving even when the water beneath it was barely deep enough to wet the keel. By the late 1930s, he had become a designer who trusted the river more than textbooks. He knew war would be decided by mobility, not by battleships or elegant fleet maneuvers, but by troops landing fast, hard, and precisely where the enemy did not expect them. While American planners obsessed over deep water engagement, focused on the grandeur of battleships and the physics of naval artillery, Higgins studied the geometry of beaches. He watched how waves broke, observing the precise moment the water lost its coherence and became a churning, shallow mess. He analyzed how sand absorbed impact, how the grain size and composition of the beach affected the grounding of a hull, and how shallow water slowed the heavy Navy craft that officers insisted were good enough. This was not abstract engineering. It was a physical, almost spiritual understanding of the littoral zone, the narrow, critical strip where the sea met the land. In his workshops, he tested hulls that could twist without cracking, boats that could grind across mud flats instead of sinking into them, and steering systems that stayed responsive even at crawling speeds, where traditional rudders would lose purchase. His approach was fundamentally different. The Navy built boats to fight the sea, Higgins built boats to fight the land. His turning point came when he started refining a design built for the harsh realities of the Gulf Coast. It had a flat bottom, a blunt bow, and a draft so shallow it practically skimmed the surface, riding on a thin cushion of water and air. Nothing about it was graceful or traditional. It was structurally uncompromising and aesthetically crude. Everything about it was intensely useful. This was the Eureka boat, a craft built not for the Navy, which prized tradition and deep water capability, but for men who had to survive the water at its worst, often miles from a proper port or a deep channel. Higgins immediately saw what the admirals could not. This strange, rugged little boat, optimized for smuggling and lumber hauling, could carry armed men directly onto a hostile beach while every other American vessel stopped helplessly offshore, mired in the shallow water their designers had ignored. The Navy was skeptical, clinging to decades of doctrine built around large fleets. They wanted tradition, not innovation, preferring modified lifeboats or heavy launches that were structurally unprepared for the violent impact of a beach landing. They trusted steel more than the flexible, resilient wood Higgins favored. They believed landings could be solved with modified launches and outdated doctrine, failing to grasp the tactical need for speed and immediate deployment. But Higgins had results. He could hit 3 inches of water at full throttle, using the momentum and the unique hull shape to slide over obstacles without destroying his craft. He could turn sharply in narrow, stump-filled channels where Navy boats stalled or broke their propellers. He could run straight into a sandbank and, instead of grounding permanently, often churn his way free with minimal effort. He invited officers to watch the tests. Some laughed before he started the engine, seeing only a crude wooden box with an engine. None laughed after. The sheer, demonstrable performance silenced the theoretical objections. Higgins kept pushing the design, viewing the water trials as continuous feedback. He redesigned the bow curvature, meticulously adjusting the angle to deflect debris and sand rather than simply collide with it. He adjusted the angle of the chins, the sharp edges in the hull, to improve stability in surf and reduce the tendency to yaw. He reinforced the boat's ribs and keel to absorb violent beach impacts, turning the act of landing from a gentle arrival into a controlled, high-speed collision. Each prototype evolved with mechanical honesty. There was no guesswork, no reliance on unproven academic models, and absolutely no shortcuts. Every improvement came from water trials where failure was not symbolic but physical. A cracked weld, a hull breach, a fouled propeller. When a hull cracked, Higgins saw a lesson in material stress. When a design stalled in the mud, he reworked the geometry of the forefoot. When a Navy evaluator said the craft was too unconventional, he built another one anyway, letting the performance do the talking. What he wanted was simple yet revolutionary. A boat that could take American soldiers from sea to shore in seconds, minimizing the deadly exposure time. A boat that could change the geometry of war, making the enemy's coastline irrelevant by turning the littoral zone from a barrier into a highway. He was getting close to perfecting the machine that would redefine the invasion. If you're still watching, it means you're finding this useful. Don't let me down. Hit the like button right now, and if you haven't subscribed yet, fix that immediately so you don't miss the next tip. When officials from the United States Navy stepped into Higgins Industries, they expected a backwater workshop run by a stubborn boat builder with oversized opinions and regional limitations. Instead, they found an operation that ran like a tightly coordinated battlefield factory. Higgins drove his workers as hard as he drove himself, instilling a relentless work ethic centered on immediate results and engineering perfection. The pace was unforgiving. Hulls were shaped from raw lumber, tested in mock surf conditions, rejected if they failed the arbitrary tests, rebuilt with modifications, and tested again. He believed engineering was a living process, not a final blueprint, and a boat only earned respect when the water approved it. Naval inspectors watched the Eureka boat skim over shallows that would strand any traditional craft, impressed by the speed but still resistant to the unconventional design. But they still saw a fatal flaw. Without a proper, efficient way for troops to exit quickly, the boat worked as a fast transport, but not as a combat landing craft. Soldiers would have to climb awkwardly over the sides under heavy fire, wasting precious, exposed seconds and turning the boat, once grounded, into a floating death trap. The Navy dismissed it again, often with condescending language. Too unconventional, too unorthodox, not naval enough. Higgins ignored the criticism about tradition and focused on the technical problem. He studied every bottleneck the inspectors mentioned, but his focus was the soldier. What he needed was a way for troops to rush forward in a single, fluid motion without losing momentum or exposing themselves unnecessarily to the enemy. He began modifying the bow, the least traditional part of his already non-traditional design. He reinforced the structure from the inside with heavy lumber and steel bracing, and began experimenting with hinged structures that could withstand the impact of a landing but still open rapidly. His team mocked up crude ramps using heavy plywood, steel braces salvaged from other projects, and the river mud as the ultimate weighing and friction testing agent. Each prototype was punished in shallow water until Higgins found a mechanism that could open cleanly, drop flat onto the sand, and, crucially, do so without fundamentally weakening the hull's structural integrity. It was an engineering stroke of genius married to battlefield necessity. What he built was a forward drop ramp that allowed 30 armed soldiers, or a small vehicle, to burst straight into combat in seconds, their weapons already leveled. The transformation was immediate and absolute. Instead of climbing over a gunwale and dropping into the surf, troops walked directly forward, maintaining their balance and unit cohesion. Instead of hesitation and delay, there was explosive forward momentum. A landing boat did not need to be pretty or adhere to tradition. It needed to be fast, reliable, and brutally honest in its purpose, delivering firepower onto the hostile beach. Higgins had created exactly that. The now iconic design was officially dubbed the Landing Craft, Vehicle, Personnel, LCVP, though it would forever be known simply as the Higgins Boat. The next challenge was manufacturing. Higgins Industries could build dozens of boats per month, but the United States needed thousands, potentially tens of thousands, to sustain a two-ocean war. Higgins realized he could not rely on traditional, time-consuming shipbuilding methods. He redesigned his entire production process, turning the construction of a military vessel into an assembly line operation, a radical concept for shipbuilding. He recruited welders, carpenters, machinists, and shipwrights from every corner of New Orleans and beyond, creating a massive, diverse workforce. Crucially, he broke down the landing craft into modular units, the hull sections, the ramp mechanisms, the engine compartment, that could be fabricated in parallel by different teams and assembled later. He taught inexperienced workers complex shipbuilding tasks by reducing each step to essentials, often designing specialized jigs and templates to ensure consistency and speed. The factory became a human engine, working with military precision. Every worker, no matter their background, learned to build for war, understanding that a perfect rib alignment was a matter of life or death. He implemented quality control with an obsessive intensity. If a rib alignment deviated by a fraction of an inch, the section was torn apart and rebuilt, regardless of the time lost. If the ramp mechanism showed the slightest hesitation or grinding, it was replaced. Higgins trusted no assumption and personally verified every claim. Inspectors who once doubted him now watched a system that outperformed larger, more established shipyards across the country. The boats came off the lines at an unprecedented speed and quality. Higgins had turned a regional workshop into a national, strategic asset. But the fight was not only against production limits and material shortages. It was also against the Navy's entrenched hierarchy, a deeply conservative institution that resisted external influence. Many officers disliked Higgins personally. He was loud, confrontational, refused to bow to rank, and carried himself with the abrasive confidence of a man who knew he was right. When admirals questioned his unconventional construction methods, he challenged them with undeniable, quantifiable test results. When procurement officers delayed orders due to bureaucratic inertia, he sent live demonstrations that publicly embarrassed them by showcasing the LCVP's superior capability over their preferred vessels. His confidence bordered on aggression, but in the environment of wartime urgency, performance spoke louder than uniformed authority. The turning point came during full-scale testing exercises involving Marine units. Marines loaded into the newest version of the landing craft, launched at speed from a transport ship, hit a shallow bar, and stormed out onto the beach within seconds of grounding. There was no hesitation, no structural failure, and no wasted motion. It was a seamless, violent transition from water to land, a perfect demonstration of the tactical advantage the boat offered. For the first time, Navy evaluators, particularly those in the newly formed amphibious forces, understood what Higgins had been trying to prove. Amphibious warfare did not need cautious, traditional engineering. It needed boldness, simplicity, and rugged dependability, all backed by proven data. The landing craft was officially approved and its production accelerated, but approval was only the beginning. As the war expanded across the Pacific and the strategic necessity of island hopping became clear, military planners realized that no major operation, from the Solomons to the Philippines, could succeed without a reliable, mass-produced landing craft. Higgins had given them one, born from the unlikely combination of New Orleans grit and engineering genius. Now he had to build enough to supply an empire-sized war effort. The scale was staggering. Production soared from hundreds of boats to tens of thousands. Higgins Industries expanded into multiple facilities, consuming enormous tracts of New Orleans waterfront, each one operating 24 hours a day in a ceaseless cycle of construction and testing. Supply chains were reorganized globally to feed the ravenous production line with lumber, steel, and engines. Material flow was optimized with a quasi-military logic. Engines, ramps, and completed hull sections were stockpiled like ammunition, ready for immediate assembly. Higgins himself walked the factory floors nightly, a relentless figure checking rivets, inspecting joints, and reviewing test logs with an intensity that workers described as almost unreal. He demanded to know the failure rate of the latest batch of plywood and the tensile strength of the new ramp cables. His boats were now everywhere. Training camps in California, Marine bases across the Pacific, coastal drills under the command of the United States Marine Corps. What had once been an unapproved design was now the undisputed backbone of America's amphibious strategy, a primary tool in the arsenal. But the stakes were rising exponentially. War was moving closer to heavily fortified beaches, where the enemy was dug in with interlocking fields of fire. The island fighting ahead, especially on coral atolls, would push Higgins's designs beyond anything he had tested on the Gulf Coast. The next landings would determine whether the Allies could successfully push across the Pacific or face catastrophic losses in the surf zone. The question remained, was the Higgins boat ready for its first true trial under sustained enemy fire? The first major test of Higgins's landing craft came not in a controlled demonstration on the Mississippi River, but in the brutal surf and unforeseen coral reefs of the Pacific. When the United States Marine Corps prepared for the assault on Guadalcanal in the Solomons, planners meticulously studied tide tables, coral reef formations, and Japanese defensive positions. They discovered that their carefully chosen landing zones were often inaccessible to traditional transports due to hidden, razor-sharp coral reefs that could shear open a conventional hull. None of the planning mattered unless troops could get from ship to shore in the fastest and safest way possible. Traditional Navy landing boats would ground on reefs miles from the beach, forcing soldiers to wade through open water, exhausted and exposed. Higgins boats, with their flat, shallow-draft hulls, often skimmed over them entirely. What happened next would decide whether his creation was merely clever engineering or a battlefield necessity. At dawn, Marines moved toward the beaches in the LCVPs with the confidence of soldiers who had finally been given equipment designed for their reality. The boats cut through shallow water, gliding over coral heads that would have wrecked other craft. Instead of slowing down as they approached the beach, they advanced in coordinated waves, maintaining a pace that confused the defenders. For the first time in the Pacific Campaign, landing operations matched the pace and coherence that commanders had envisioned but had never achieved. Marines hit the beaches quickly, moving with momentum and operational coherence. Higgins's design had not just worked, it had fundamentally transformed the nature of amphibious warfare from a slow, cautious process into a rapid, decisive assault. Reports poured back to New Orleans. The boats handled complex surf patterns better than expected, carried heavy equipment, including artillery pieces and early jeeps, and consistently delivered troops where charts claimed no boat could navigate. Higgins read every field note sent back to him, treating the combat reports as the ultimate laboratory data. Where soldiers saw reliability, he saw specific opportunities to refine the next batch of production. He immediately improved the hull stiffness to prevent flexing under heavy loads, adjusted the angle of the ramp door and its hinges to ensure flawless deployment under tropical corrosion, and strengthened the framing around the bow to survive the shock of repeated, violent beach impacts. Field testing did not just confirm his work, the pressure of combat accelerated its evolution. But Guadalcanal was only the beginning of a long campaign. The island-hopping strategy demanded a new type of engineering logic. American forces continually needed to assault beaches fortified by bunkers, machine gun nests, artillery, and concealed positions. Every minute saved in troop deployment meant fewer casualties. Every second troops spent climbing over a gunwale rather than charging forward invited concentrated enemy fire. The Higgins boat reduced those critical seconds to zero, delivering infantry, supplies, and light vehicles with a consistency that surprised even hardened officers. By the time of the catastrophic operations at Tarawa in late 1943, the stakes had become far higher. The Japanese garrison on the tiny island was heavily entrenched, and military intelligence had gravely underestimated the tidal conditions. Standard, deeper draft landing craft grounded catastrophically on the exposed coral reef hundreds of yards from the beach. Hundreds of Marines were forced to wade through the chest-high water under devastating crossfire. Higgins boats, though struggling in the heavy surf and also grounding on the reef, became the only vessels capable of bridging the gap between the treacherous reef line and the beach itself. Troops who would have been stranded and annihilated in open water were shuttled to the front under fire. War reporters documented the chaos, the brutality, and the immense resistance on the shore. Yet, amid the loss and confusion, one fact stood out. Without the shallow-draft Higgins boats, the entire landing force would have been decimated before even reaching the sand. The boats saved lives by enabling the impossible. The pressure on production back home grew stronger, turning Higgins Industries into a non-stop national resource. The facilities ran around the clock, building not only the LCVPs, but also larger landing craft, LCMs, patrol torpedo, PT boats, and specialized support vessels for the rapidly expanding United States Navy. The demand seemed utterly endless. Workers from across Louisiana, including shipbuilders, welders, and laborers with no previous maritime experience, adapted to Higgins's famously strict and accelerated process. Training routines were compressed and hyper-focused. Material flow was reorganized through sheer logistical will. Efficiency was pursued relentlessly, sometimes at the cost of the crew's sleep and well-being. Higgins truly believed that war waited for no one and that any production delay cost lives on a distant beach. He began diversifying the landing craft line to meet emerging needs. Larger models were developed specifically to transport vehicles and heavier cargo. Smaller, faster variants supported reconnaissance missions and special operations units that required surgical insertion and extraction. Every single design shared the same core philosophy. Boats must operate effectively in dangerously shallow water, handle violent impact, and deliver troops directly toward the objective with minimal exposure. It was a simple, brutal vision that demanded relentless, iterative engineering. Higgins accepted the crushing responsibility personally. He reviewed blueprints daily, inspected welds himself, and questioned any step in the manufacturing process that did not demonstrably increase the boat's strength, reliability, or speed. Technicians recalled that he carried field reports, often smudged with mud and blood, like sacred operational documents. Notes from the Pacific Theater directly influenced every new model. He made incremental, microscopic adjustments that accumulated into sweeping improvements. The ramp hinge received crucial reinforcement to prevent jamming during rapid deployments under fire. Hull curvature was subtly modified to reduce the violent slamming motion in heavy surf. Bulkhead spacing was redesigned for higher durability after sustained fire. Nothing remained static. A Higgins boat built in 1944 was structurally and mechanically a significantly more advanced vessel than one built in 1942, yet the core silhouette and function remained unmistakable. As the Allies prepared for the massive amphibious assault on the Philippines, commanders relied on Higgins boats as the absolute backbone of their landing strategy. War planners recognized that large-scale operations were now logistically possible only because the equipment existed to support them. Higgins had turned a profound logistical and doctrinal weakness into the single greatest operational advantage of the Pacific Theater. The landings at Leyte and Luzon demonstrated this with devastating clarity. Troops surged forward in coordinated waves, supported by equipment that arrived exactly where it was needed. The boats took damage from mortar and machine gun fire and, due to their robust construction, often kept moving. They grounded on hostile shores, remained structurally intact, delivered their infantry and cargo, and returned immediately for more. But the conflict in the Pacific was approaching its climax, and the European theater was simultaneously heating up. After years of battles across jungles, reefs, and volcanic sands, the United States was preparing for its most ambitious, most complex amphibious assault of the entire war, an operation that required unprecedented cooperation between the Allies. The next target was an island so heavily fortified that military planners predicted casualties on a scale not yet seen. Higgins knew the coming operation would push his designs beyond every previous limit. Would the boats that carried the first Marines onto Guadalcanal withstand the most dangerous, decisive landing of the entire Pacific War, or the simultaneous, massive invasion of Europe? By early 1944, the Allied strategy had reached its most critical and complex phase. 2 oceans, 2 geographically distinct fronts, and 1 critical requirement defined the war's next chapter. The United States and its allies needed to place hundreds of thousands of soldiers and tons of equipment onto hostile beaches with precision, speed, and overwhelming, continuous force. Conventional, deep-draft transports and landing craft could not meet that simultaneous demand. It was now abundantly clear to every planner in Washington, London, and Allied headquarters globally that Higgins boats were no longer merely useful support vessels. They were, tactically and logistically, the single most critical component of Allied amphibious warfare. No operation demonstrated this necessity more clearly than the landings on Normandy. As the immense invasion fleet, Operation Overlord, moved across the English Channel, hundreds of Higgins boats, painted in drab military green and packed shoulder to shoulder with soldiers from the United States Army and the United States Navy, prepared for a mission designed around a single unforgiving principle: troops had to reach the beaches and exit the craft as fast as humanly possible. Fire would be heavy and sustained. The shingle and sand terrain would be brutal. The first hour of the landing, the period of maximum vulnerability, would define the success or failure of the entire invasion. At dawn on June 6, 1944, the ramp doors of the LCVPs dropped onto the beaches of Omaha and Utah. Soldiers rushed forward into the maelstrom. Bullets tore into the surf and the wooden hulls. Artillery shook the sand and the water itself. Yet, wave after wave, the Higgins boats kept coming, running the gauntlet. Even when German defenses pinned the initial units down in the sand, the boats continued delivering new waves of reinforcements, medics, ammunition, engineers, and critical supplies under conditions that would have instantly destroyed slower, heavier, or more traditionally designed craft. Allied commanders, including the top brass, later acknowledged with absolute certainty that without the sheer volume and rugged reliability of the Higgins boats, the landing force would have been fragmented, disorganized, and critically delayed, potentially leading to a catastrophic failure of the initial assault. Instead, the assault maintained coherence, momentum, and scale despite the horrific casualties. Where most war machines were designed for specific, controlled environments, Higgins boats adapted to all of them. The same craft that ferried soldiers ashore during the invasion of Normandy also advanced in the Pacific theater, often within weeks of each other. The same ramp that carried soldiers ashore in France also carried battle-hardened Marines onto the volcanic beaches of Iwo Jima and the coral atolls in the final push toward Japan. At Saipan and Iwo Jima, two of the most hellish battles of the Pacific Campaign, Higgins boats battled violent, unpredictable surf, volcanic ash, and constant smoke. They delivered marine riflemen and their heavy equipment to zones where artillery struck so close that the light wooden hulls rattled violently under the impact. Many boats were damaged, but incredibly few failed completely in their primary mission. The design philosophy that shaped these vessels, rugged, functional, and simple, proved resilient under the most extreme conditions. This resilience was not accidental. It evolved through constant iteration and a commitment to learning from failure. Higgins understood that reliability during war was not a static trait. It required constant, accelerated refinement shaped by real combat data. After every major operation, his engineers reviewed battle damage reports, structural stress analyses, and component failure logs. Higgins personally analyzed cracked welds, bent ramps, and dented hulls from returning boats, treating each failure as a flaw to be engineered out of the next production run. Each failure became a specific blueprint for the next improvement. Bracing patterns were strengthened. The impact tolerance of the ramp mechanism was increased. Engine compartments were reconfigured for faster, simpler maintenance in the field by inexperienced crews. Production surged to unprecedented levels. Higgins Industries, once a modest boat workshop in New Orleans, expanded into an industrial network employing tens of thousands of workers, welders, carpenters, engineers, and laborers from every background imaginable. The workforce became a powerful national symbol of American industrial ingenuity and unified purpose. Some employees had never seen the ocean before. Others had never worked with tools before joining the assembly line. Higgins trained them, pushed them, and demanded quality standards usually reserved for precision aircraft factories. His core philosophy was brutally simple. A flaw unnoticed at the shipyard could easily become a fatal weakness on a hostile beach half a world away. He diversified production continuously to meet the emerging strategic demands of two simultaneous global conflicts. Larger landing craft, mechanized, LCMs, capable of delivering tanks and heavy armor were developed specifically for European operations where armor support was critical. Smaller, faster versions supported reconnaissance teams and special units that required high speed and stealth. Engineers refined drainage channels, strengthened bow framing further, and optimized the boats for rapid turnaround during prolonged operations. Every single variant, whether a tiny utility boat or a large tank lighter, carried the same core principle that defined the first prototype: deliver men and equipment directly onto hostile territory faster than the enemy can respond or recover. By 1945, military strategists and historians later recognized a foundational truth. Higgins boats made large-scale amphibious warfare possible, not simply easier, but possible. They allowed Allied forces to launch massive, simultaneous landings across multiple regions globally. They enabled logistical chains that stretched from distant carriers to the beaches with a precision and volume previously unimaginable. They supported operations that required perfect timing and relentless, unified momentum. General Dwight D. Eisenhower, the supreme commander of the Allied forces in Europe, later summarized the significance of the unassuming wooden boats with a statement that became an enduring part of Higgins's legacy. He famously declared that Andrew Higgins was the man who won the war for us. He won it not through dramatic speeches or battlefield heroism, but through engineering, through the creation of reliable, simple machines that soldiers trusted with their lives, through an idea that turned shallow water reefs and beach obstacles from impenetrable barriers into navigable pathways for the assault force. As the war neared its end, Higgins faced a different, final challenge. The enemy was weakening, but amphibious operations were intensifying in preparation for the final, brutal campaigns. The planned invasion of the Japanese home islands, Operation Downfall, required the largest landing force in history. Millions of soldiers, thousands of ships, and hundreds of miles of heavily fortified coastline were expected to form the final, decisive stage of the Pacific Campaign. Higgins knew what this meant. His boats would carry the first wave into the teeth of the most fortified defensive positions ever constructed, where the resistance would be fanatical. The war ended before that invasion occurred. The final, ultimate test never came to pass. Yet the tools he created had already fundamentally reshaped modern warfare. His designs influenced post-war naval doctrine, the structure of amphibious fleets globally, and the development of military engineering for decades to follow. The boats themselves became enduring icons of the conflict. Their silhouettes appear in virtually every iconic photograph of Normandy, Saipan, Tarawa, and dozens of lesser-known but equally critical landings. The true legacy of Andrew Higgins is not defined by a single invention, but by the transformation of amphibious warfare from a risky, often impossible maneuver into a disciplined, repeatable, and highly coordinated military system. His boats arrived where others failed. They carried the men who turned the tide of the war in both theaters. And they proved that engineering, when driven by a profound clarity of purpose and a relentless focus on the soldier's need, can fundamentally alter the fate and strategic balance of nations. The question lingers: would another global conflict ever again rely so completely on the vision of one single engineer who saw mobility and utility as the ultimate weapon? Thank you so much for watching until the very end. If you found this valuable, please like the video and share it with one friend who needs to see this. Your subscription helps this channel grow. Join the community now.